Alright, so this is just a video I'm going to submit alongside my final project submission, just explaining the code. So what we have here is the clock, the different switches that depend whether or not you want to switch the values. We have switch 14, which shows you that fifth die roll value, and we have the reset switch. All the LED activations, all the 7 segment stuff, and we have the action buttons declared here, which actually roll the die. So we go into our design here, and we have our module as Yahtzee with all the inputs and outputs, the LED and the 7 segment outputs. We have all these registers to hold the value of the die. We have this clock that I found online, but I changed things around so it fit exactly what I wanted it to do, which was make it a bit slower so you can actually see the LEDs change and the designs appear to the human eye. Otherwise, it's too fast. And we have this debounce code that was the same for the button debounce lab. And we have the debounce for die 1, die 2, die 3, die 4, and die 5. We have the, this is a enable anode refresh sequence that basically just goes through the anodes all the time and makes them turn on so fast that it looks like they're all on at once. So you can write to them whenever, instead of just activating one at a time. This is a dice roller where it counts 1 through 6 repeatedly all the time, and when you press a button, it takes whatever value this is at that time and places it in the value of the specified die roll. And this is just a register for a count that basically works as our state machine. So this is that count is less than 1, which it starts out at 0. You start this, and if you click the button, then the die 1 value then goes to the value that dice roller was. It's the same for the second, third, fourth, and fifth. And at the end here, we have our count going to a specified value, which then activates this if statement. So that's like from state 0 now to state 1. And we have the same thing, except for now the values are switched on not only the click, but also the switches being activated. And it's the same thing all the way down. If die 1, die 2, die 3, and their respective switches are flipped, the value changes. Otherwise, leave it the same. And our count goes to this specified value, which then activates this if statement. And the third die roll sequence is the same as the second one. It's just that the count here at the end goes to this specified value, which then changes the state and activates this if statement, this else if statement right here. And then we have at the end all of our values. They get compared against each other, where if die 1 equals die 2 equals die 3, blah, blah, blah. If you get 5 of a kind, count goes, if you get 5 of a kind, and this is just a reset clause, then you activate these LEDs in this sequence, which is just like the victory sequence that I showed in the video. And then this was just other sequences that I could have chosen. And then else, die 1 does not equal die 2, does not equal die 3. Else there's not 5 of a kind. Then the LED plays this. That is just another reset clause. The LED does this very lackluster celebration where it's just 4 zeros, 5 ones, and the rest are zeros. So it's just a slow blink, which means that you lose. And then here are all the ends for all the if-elses that I had up there. And then at the very end here, this is always running. Our cathodes change based on our different values, which is actually like the heart of the 7 segment. So say die 1 value is 5. Now the cathode input will be 5. And we have this if switch 14. This is when you hit switch 14 and see that like value behind the scenes, like the 5th value. This is what controls that and gives you the anodes to be fixed at a certain point here. And you can kind of see that here. That arrow means like it's behind the scenes. This one activates the first, second, and third, and fourth here, as depicted by that X. And then we have the 7-segment activator here, which actually like turns on as these die 3 and die 4 values change. So did this case statement here. So this here controls the anodes and defines which anode goes to which die value. And this here controls the cathode input of each anode. And then that ends the module. And then I have this thing down here that I was referencing the whole time that just goes through 0 through, what is that, V. And that's the end of my code. I know right now it says reaction timer up there, but that's just because I've been copying my .v file and reusing it. So when I turn this in, it'll be Yahtzee.v. So don't be alarmed by that. Thank you.